Hello everyone, my name is I M Iqbal. I am going to present my paper on electrical properties of conductive concrete containing graphite. My co-authors are Paul Choi, Nazmul Islam, and Dr. Philip Park. We all are from the University of Texas, Rio Grande Valley, Edinburgh, Texas. I would like to express my gratitude to the Canadian Society of Civil Engineering for organizing this conference and giving me the floor to present my paper. Presentations outlines, I will provide some introductions on my research, and then I will describe the why we're going to do this research or problem statement, then the objective of my study, methodology that we have used, and specimen that we have prepared, and also the test setups. Finally, result discussions and conclusions. So concrete is composed of Portland cement, aggregate, and water. If we add some conductive fillers, that could be carbon nanotube, carbon fiber, or graphite, that forms a conductive composite, and we call it's actually a conductive concrete because it has some conductive materials. This conductive materials is called smart materials because it serves several non-structural applications such as strain sensing, damage sensing, temperature sensing, and some other freeze monitoring of freeze for damage sensing, de-icing and snow melting of road. Most of these non-structural applications depend on the electrical properties of conductive concrete. Therefore, understanding and proper measurement of electrical properties of conductive concrete is necessary. That's our main focus of this research. And it all used a carbon nanotube to measure the conductivity of concrete, and they concluded that the conductivity data of concrete measured in DC are inconsistent. So some researchers used continuous monitoring, and there is another method that called discontinuous monitoring is available. So we are going to actually thoroughly investigate available test methods for the DC measurements because a lot of study has been done using DC measurement for the self-sensing applications. Moreover, impedance spectroscopy using alternating current in various frequency ranges can be a better method to characterize the electrical properties of conductive concrete. That's we are going to focus. So the objective of our research is to investigate the electrical properties of graphite-added conductive cement paste using both DC measurements and AC impedance spectroscopy. We use two different DC measurement techniques. One is continuously connecting probes and connecting and disconnecting the probes on a specimen. We also use three different devices to compare the consistency of the results, and also we observe the effect of voltage and the effect of moisture on the electrical properties of conductive concrete. As we said, we will use direct current and alternating current. So in case of the direct current, the voltage will remain constant and electricity will flow in the same direction. One directional flow, there will be some positive charge in one side of the specimen, and another side there will be some negative charges. So this will increase over the time, and due to this, the resistivity will increase. So this is called the polarization effect. And on the other hand, if we use alternating current, once at some point it will be positive, and at some point it will be negative. So what will happen? The negative charge will be neutralized by the positive charge. So there will be no polarization or no charging effect. And so for this reason, we can say alternating current is a better approach than the DC measurement. And from the alternating current, we generally obtain two graphs. One is called body plot, and another one is called Nyquist plot. In the body plot, we obtain impedance versus the frequency graph, and in the Nyquist plot, we obtain the imaginary impedance versus the real impedance graph. And if there is some inductance in the specimen, then the impedance goes up with the impedance with the frequency, and if there is some capacitance effect, impedance goes down with the increase of the frequency. As the main ingredients, we use cement, water, and graphite. We added graphite at the 3% by volume of cement paste, and after curing for 28 days, we applied silver paste, and then we wrapped with the copper foil as electrodes. We keep them under water for making it fully saturated. We keep them oven for making it fully dry. In both cases, we wrap them with the plastic to control the moisture so that moisture doesn't go out or go inside the specimen while the measurement. And for the graphite, we use A516 type graphite, which is flaky type graphite, and we collected this from Asbury Carbon Incorporation. And graphite is more economical and it has a very low resistivity. We prepared 3 specimens from the same mixture, and all of their dimensions were same, their cross-sectional area were same, and water cement ratio was 0.45, and we used 3% of graphite powder by volume mix. For the test setup, we use 2-point sensing, as you can see from the figure, and this is our positive electrode and this is our negative electrode. DC measurement, we used actually 3 different DC measurement equipment. One is Kately, one is P3772 multimeter, and one is digital multimeter DM441B. And for the AC measurement, we use Metronome Autologue Physistat 302. And in case of the AC measurement, we used only 0.5 voltage, and frequency range we used 1 megahertz to 1 hertz. And for each impedance value we obtain, we use 10 cycle of sine wave. Now look at the results and discussions that we have obtained from the static or DC resistivity measurements using different instruments and different conditions. Figure A is showing that the specimen at dry conditions, and we use Kately, and figure B showing a specimen at wet conditions, we use Kately at 1 volt, and we can see that in both conditions the resistivity is increasing over time, and at the initial, the resistivity increase was much higher. And another thing is that we do not get a similar or repetitive pattern for the same specimen or same mixture. So that's one of the drawbacks that we have obtained. And also, we use multimeter for the specimen in the wet conditions, and we also seen that the resistivity is increasing over time. So what you can say, in case of the continuous monitoring, our resistivity is increasing over time. In the discontinuous measurement, we used for we measured the resistivity with the Kately and the multimeter one at the dry conditions for 2 hours, and for the multimeter 1 and multimeter 2 for 8 hours. What you can see, for a single specimen, we are getting a consistent value over time, resistivity over time. However, if we change the instrument, then the resistivity is not remaining fixed. So what I can say, with the different instruments, our specimen is showing different resistivity value. It is because the instruments voltage is not, we don't know, or only we know about the Katleys, but for the multimeter 1 or the multimeter 2, it's very difficult to know the voltage. So to validate these issues, we also observe the effect of voltage on DC measurements, and we have seen that both continuous monitoring and discontinuous monitoring, with the increase of the voltage, the resistivity is decreasing, but for the continuous monitoring, it's increasing over time. For the discontinuous monitoring, it's showing almost a consistent value. So the reason the discontinuous monitoring is showing a consistent value is that when we connect the specimen continuously, then as we discussed, there is a charging effect. But when you're disconnecting after getting the value, the charging effect is not that much. So that's why we are getting the consistent value. Now, from these results, we can conclude that actually with the various conditions, with the various instruments, and our DC measurement is not showing consistent value. We also measured the electrical resistivity using the AC impedance spectroscopy. The left figure is showing the specimen impedance results at the dry condition, and right is showing at the wet conditions. We can see that for a same specimen, it's showing consistent value, and for the same mixture, there is a slightly difference because due to the graphite proportions is not almost homogeneous. That's a slightly difference, but almost consistent. And we can see that our resistivity or impedance is decreasing with the increase of the frequency. As we know, if there is some capacitance inside the specimen, then this phenomena is obvious. This phenomena is visible. So we can say there is some capacitance effect inside the specimen, and AC impedance spectroscopy gives very consistent results with compared to the DC measurements. And another thing we can see from the wet and dry conditions result is that our wet specimen impedance is almost 1000 times lower than the dry specimen results. In case of the Nyquist plot, there is a fairly consistent results for the dry specimen, but for the wet specimen, we all observe a fairly consistent results, and we observe semicircles and also the tail pattern. That's it's a typical cement composites behavior under AC impedance spectroscopy. So the conclusion is that the moisture plays a significant role in electrical resistivity measurement. And for every test, dry specimen shows higher resistivity than wet specimen as expected. The results also show that the graphite and cement pitch has both the characteristics of capacitance and resistance. And the body plot shows the electrical resistivity decreases with the increase of AC frequency, and the continuous monitoring using DC shows the increase of resistivity with time. This indicates that the specimen behaves like a capacitor. Due to the charging effect in DC measurement, the measured resistivity values are not consistent, and the measured resistivity decreases with the increase of the voltage. On the other hand, the body plots and Nyquist plots obtained from by AC impedance spectroscopy showed consistent results when the moisture concentration is identical. And moreover, we can see that our resistivity is varying with the frequency, so we can't have a very single resistivity value for our specimen. And we need to measure electrical properties by AC impedance spectroscopy. So these are references that I have used for these presentations. And thank you all for listening for my presentations. If you have any questions, please let me know. I'll try my best to respond. Thank you so much for your time.